All right, welcome back everybody. Today we're going to be talking about converting DC into AC, the current solutions available to do so, EcoFlow solution, and key features, and also some relevant efficiency data towards the end. Let's get into it. Let's take a look at DC versus AC. DC stands for direct current, and as you can see here by this straight line, this is a direct and continuous voltage. Now AC stands for alternating current. As you can see here by this waveform, this is an alternating and variable voltage. Now anything that requires an AC input, which is basically everything in a home, cannot work with a DC input. All right, so this green line represents a square wave. The blue line represents a modified square wave. Now, these two inverter types are easier to manufacture, they also cost less, but they have some drawbacks, like poor device compatibility, low power output, and high risk to damaging electronics. So these are not a good option. What we've done is decided to go with a pure sine wave, which is represented by this red line. And unlike the other two, this poses no risk to damaging electronics. But on the other hand, it's more complex to manufacture, costs a little bit more, but it's worth it because this is the safest option. And this allows us to build a more intelligent inverter. So I'm gonna get into that later in the video. But first, I want to take a look at high frequency inverter topology. Okay, so this is the TI design reference for a bidirectional high frequency inverter. You can think of this like a house. Each of these components are building blocks. Now, while every home requires a foundation, a floor, walls, and a roof, they can be configured in any way that you need. If anybody wants to take a closer look at this, the link will be down in the description. And let's take a look at how EcoFlow has configured these. All right, let's take a look at our configuration. So because this is a bidirectional high-frequency inverter, you have an AC input here, which will go through a bypass directly to the AC output, while simultaneously charging the battery. If this connection is ever interrupted by a power outage or gets disconnected, the inverter will switch modes from charging to discharging, and the battery will begin supplying power to the AC outlet. All right, let's take a closer look at the EcoFlow inverter. Just like the chart, you have the AC input here. This is going to follow a path down to the bypass and directly out to the output. And at the same time that this is happening, it's also flowing this way down to this battery connector to charge the battery. If this connection is ever interrupted, the mode will change and the flow now goes this way to this relay and out to the output. This all happens within 30 milliseconds. So now that you've seen how we've configured our EcoFlow inverter, I want to talk a little bit more about our key features. All right, so the first key feature I want to talk about is the extreme charging and what it's capable of. So I'm going to get this out of the way, pull this a little bit closer so you guys can see. And I'm going to plug in the AC input, and you'll be able to start seeing the input watts climb. So 100, 200, 300, this should go to about 500 watts. 400, 499, okay, 500. So this is going to allow you to charge extremely fast. And the reason this is possible is because the way that we configured the bidirectional high frequency inverter. So I'm going to unplug the AC input and show you the next feature, which is X Boost. So we have the trusty 1200 watt hair dryer. I'm going to plug into the AC output. And I'm going to grab my multimeter so that you can see this is displaying the voltage. So we're at 120 volts right now. So I'm going to turn this on max. So as you can see, it dropped to about 80 volts, 81 volts. And the display on here shows an output of 600 watts. And on the oscilloscope, you can see that it's remained a pure sine wave. And now it's returned to 120 volts. So this is how the X Boost feature works. And the reason for this is it's based off of Ohm's law. So this equation is very important for the function of this feature. Okay, so next feature, we're going to talk about extreme bypass. I'm going to show you how it works and give you a little bit more information about a key safety feature. So again, we're going to plug in the AC input and plug in the hair dryer, this is a 1200 watt hair dryer. So you can see the AC input's working, it's charging. Now I'm going to turn this on the lowest setting first. So it's pulling about 90 watts. Now the medium setting, this is pulling 470 watts. Let's see what happens when I put it on the highest setting. Okay, so this triggered the overload protection system. This is actually a key safety feature that we've implemented to keep you and the device safe, because when this device is in extreme bypass mode, we don't have the ability to control the voltage like we do during the X-Boost feature, the X-Boost mode. So what happens is this 1200 watt device is going to try to pull as much as it can from the AC input. This could damage the electronics, possibly cause a fire. So the reason this safety feature was implemented, again, is just to keep you safe, keep the device safe. So if you're going to want to use a device while the AC input is connected, we recommend that you use something under 600 watts. If you want to run something that's over 600 watts and use the X-Boost feature, just disconnect it from the AC input. While we have all this connected, I also want to go over the UPS function. So the way this works is we're going to turn the inverter on. Okay, so AC in, device on the other end. It's running. We're at 470 watts again. What I'm going to do is disconnect the AC input. So you can see here, this is the actual point when the AC input got interrupted. So the delay is it's under 30 milliseconds. So this is considered an entry-level UPS. And because of what's going on, we have to go from AC to DC, and then we have to go from DC back to AC and out. This process takes time, so it makes it difficult to get this number lower, but we're working hard on reducing this delay. All right, so last but not least is our X-Link feature. Now this is actually our most complex feature, and which is why you haven't seen this implemented in a portable power station like the R600. This does exist in things like gasoline generators, but never a portable power station like this. This gives us a big advantage and enables you to have a higher power output and capacity simply by connecting two R600s together. It's as easy as that. All right, so I just wanted to circle back around and highlight a couple things I mentioned about the extreme bypass safety feature and the UPS function. So for the extreme bypass, the reason the overload protection system gets triggered is because the AC input only has a 900 watt max, and there's a 300 watt reserve for the battery. And this output has a 600 watt max, so there's only a usable 600 watts. The great thing is most home appliances like TVs, personal computers, lights will fall below this power demand. But if you need to use something that has a higher power demand, like a hairdryer, coffee machine, anything with a heating element, you can simply unplug the AC input and leverage the X-Boost feature. Now for the UPS, the reason we call this entry level is because of the 30 millisecond delay time. The industry standard is around 10 milliseconds. So because of the complexity of our system, it takes a little bit longer. But if you're powering TV, computer, lights, whatever it may be, the devices will stay on and remain functional. And we're working really hard on refining this process and increasing the efficiency. Okay, so another great advantage of our inverter design is the fact that you don't need a power adapter. This opens up the doors for faster charging, smaller inverter volume, and a wider range of use case scenarios. Let's take a look at this inverter discharge efficiency. You can see here on the x-axis, this is watts. The y-axis is discharge efficiency percentage. Now, if you're using a device that's below 100 watts, it's recommended that you use the DC output. It's just going to be more efficient this way. So these three lines represent varying voltages. You can see here this blue line peaked at 300 watts at an 88% efficiency. And the others didn't suffer much loss of efficiency up to the 600 watt max, and all remained above 80%. Okay, something to keep in mind about these high frequency inverters is this is the next advancement in inversion technology. There's a lot more processing complexity, but it significantly increases overall system efficiency. It does pose a couple challenges, like achieving zero voltage switching, which we've successfully done. So I really hope you enjoyed this video. I hope you learned something. In the next video, we're going to be talking about battery technology. So we'll see you then.